We want to find the antiderivative or evaluate the in-depth integral. Let's begin by factoring out the 9 and write this as 9 times the integral of x to the 5th cosine squared x to the 6th dx. And now because we have x to the 6th here and x to the 5th here, we'll perform U-substitution and we'll let u equal x to the 6th, and therefore differential u is equal to 6x to the 5th dx. And since we have x to the 5th dx, let's divide both sides by 6. And therefore 1/6 differential u is equal to x to the 5th dx. And now let's write this in terms of u. So we'll have 9 times the integral of x to the 5th dx again is equal to 1/6 du. So we'll factor out the 1/6 and we have differential u, and x to the 6th is equal to u. So we have the integral of cosine squared u. Now we've made some progress here, but we don't have an integration formula for cosine squared u, so we'll have to apply the power reducing formula given here below, where if we have cosine squared u, that's equal to 1/2 times the quantity 1 plus cosine 2u. So we have 9/6 here, which is 3/2, times the integral of, when we perform this substitution, notice how we'll have a factor of 1/2, which we'll factor out. So we have 3/2 times 1/2 times the integral of the quantity 1 plus cosine 2u. And now we'll find the antiderivative with respect to u. Notice here we have 3/4. The antiderivative of 1 with respect to u would just be u. And we need to be careful when integrating cosine 2u. This would require a substitution. We've already used u, so if we use v and let v equal 2u, notice that dv is equal to 2 du, and therefore notice that du equals 1/2 dv. So we'd have an extra factor of 1/2 when integrating. So we'll have plus 1/2 times the integral of cosine v, which would be sine v, and we know v is equal to 2u. So we have 1/2 sine 2u, and then plus c. So writing this in terms of x, we would have 3/4 times u, which is x to the 6th, plus, here we have 3/4 times 1/2, that would be 3/8, sine 2u, which is 2x to the 6th. This would be our antiderivative. I hope you found this helpful.